Welcome back to TrainSignal's VMware vSphere 5 training. You're watching using the vSphere Distributed Virtual Switch, otherwise known as dvSwitch. Okay, so a quick disclaimer here before we get started. You're probably going to hear me say VDS and vNetwork Distributed Switch probably all through this lesson, just because I haven't been accustomed to saying vSphere Distributed Switch yet. Now, prior to version 5, the vSphere Distributed Switch used to be known as the vNetwork Distributed Switch, the VDS. So, just in case I use that term so you know how I'm using it a little lightly here, but I'm hoping that you guys can follow along. So, in this lesson, what are we going to cover? We're going to talk about the vSphere Distributed Switch. So far in networking, all of what we've covered has been around the vSphere or the vNetwork or the vStandard switches. We haven't talked about any kind of advanced virtual switching. Now, in this lesson, we're going to cover the vSphere Distributed Switch, which allows you advanced functionality, allows you to manage things centrally. We're going to talk about private VLANs. This is a concept, again, that's only available with the vSphere Distributed Switch. We're going to talk about the differences in networking policies. There are some networking policies that are only available with the VDS, where others are only available with the VSS, the standard switches. And then we're going to discuss the different configuration tasks that we're going to tackle during this lesson. Now, what vNetwork Distributed Switch does is it takes the best of the standard switches and centralizes it. The problem with the standard switch is that it's isolated, or that it's limited to the ESX host that you're working on. So if you have 10 ESX hosts in your cluster, now you got to take all the configurations you've done on the first one and replicate those changes across the other 9 that you have in order for you to get a standard networking configuration, so that features like vMotion can work properly, because they'll need the same type of switch on all the other hosts so that this virtual machine can migrate between all of them. It also needs all the other port groups and switches that are available on the original host in order for it to communicate on the same VLAN and make sure it has access to the same network and subnet that it's when it moves from ESX host to ESX host. So this can be very cumbersome, especially if you have large clusters. Now, the whole idea of virtualization is that we want to make things easier, and as we move towards virtualization in a complete fashion, we want to have the ability to have centralized management. We don't want to have to go from each ESX host to make these configuration changes individually. So what vNetwork Distributed Switch gives us, or brings to the table, is a centralized virtual switch that can span multiple ESX hosts. So instead of making a change on each ESX host, you now make it on a centralized virtual switch, and any host, any ESX host that is subscribed to this virtual switch gets access to the same port groups, same subnets, same networks, etc., so that you don't have to make these multiple changes. You can see how this can reduce configuration and change time, because again, you're not having to do this multiple times. This also reduces the window of error because you're doing it once. Now, a vNetwork Distributed Switch, otherwise officially abbreviated by VMware as a VDS, has what's known as a DV port. Now, DV port groups are the equivalent of port groups in a standard virtual switch. In order for you to distinguish them, they're called DV port or DV port groups. The switch in a VDS environment would be called a DV switch. Now, moving on to some additional features that you get with the VDS, you get the ability to do private VLANs. Now, what is a private VLAN? Why do I need it? What is it exactly? So a private VLAN is a way for you to subdivide a VLAN. So today you have a VLAN, all the hosts can be part of that VLAN, but if you wanted to further isolate further groups of hosts, you can do sub-VLANs. Now, sub-VLANs are easier to configure, so if you needed to have hosts in isolation or hosts in community, etc., you can do that with the use of a private VLAN. Now, the way you create a private VLAN is you're going to take an existing VLAN, the way it is. That's otherwise known as the primary VLAN. It's the original VLAN. Now, that original VLAN can have multiple secondary VLANs. What happens with secondary VLANs is you're going to get a VLAN ID that you get from the primary VLAN, and then you're going to get a subset of that VLAN ID. So every packet that goes in and out of the secondary private VLAN gets an additional ID tagged to it so that you can identify it. So that the switch that's connected to, the physical switch that it's connected to, can understand that the packet that is coming has a VLAN ID of, let's say, the original VLAN was VLAN 1. The secondary private VLAN is 12. So the packet would look like 1.12. And I'm going to show you when we go into the GUI configuration, this will be a little clearer, so it's a little confusing here, how you can append that ID to the original VLAN ID so that the physical switch that the packet is communicating with can understand where this is destined to. Now, you can have multiple secondary private VLANs, and they have three modes: either promiscuous, isolated, or community. And we're going to talk about this in the next slide here, but I just want to give you a general overview. I know this might not be very clear right now, but I'm going to show you a figure that further clears up this, but it's going to become very clear once we go into the GUI, because I'll be able to show you how you can tag this ID. So let's move on to defining what the promiscuous, the isolated, and the community mode for a secondary private VLAN can do. Now, a promiscuous port is typically associated with a router. A promiscuous port can talk to any other port group or any other mode. So it can talk to the isolated and it can talk to community. Now, what isolated is exactly what the name implies. You put a host in an isolated secondary private VLAN, and the only port it can talk to is that promiscuous or that router node or port. Now, a community means that you can have 2, 3, 4 multiple hosts in that community that can talk to each other and also can talk to the promiscuous port. Now, the community can also send packets to any other secondary private VLAN, any other community secondary private VLAN. So if there's multiple secondary private VLANs that are community, then they can talk to each other, and obviously they can talk to hosts that are part of their community and with the promiscuous port. Now let me show you an illustration of what a private VLAN can look like. Again, this is going to be very clear once we log into the GUI and we start doing some configuration. But the idea here is you see the main VLAN, and then you see the secondary private VLANs. So we have 5 secondary private VLANs. You have 2 that are community, tagged in green. So they can talk to each other, and the hosts that are within these communities can obviously talk to each other. And then you have the red, which is isolated, only has one host, can talk to the promiscuous, which is the router, but that's the only thing it can talk to, and you can see that those are isolated. And then you'll see in blue you have the promiscuous, and I put a router in there just to illustrate that most often it's a router. Now, you obviously can also have hosts in the VLAN that are not part of any secondary private VLANs. They're just hosts that are added to a VLAN. So all of those can talk to the switch, etc., etc. Moving on to networking policies. Now, for the most part, the networking policies between the standard switch and the VDS are somewhat similar. Now, the VDS obviously has significantly more advanced policies and features and stuff like that. But the two that I want to really call out, the two that are the sort of the main differences, are VLAN, which is available with VDS only, and that's a little misleading from just a title perspective, VLAN, because there was VLAN support in standard switches, except the VLAN support there is limited. With the VDS, what you can do is you can now have your virtual networks join physical VLANs. So the VLANs that you create and configure on your physical switches, well, those VLANs can now be joined by virtual networks as well. The virtual network can join them, and that is a feature of VDS that I'm sure your network administrator will be happy to hear about. The other one is port blocking, and it's pretty self-explanatory. It allows you to do blocking of certain ports at the port group level, so that if you wanted to block them or stop them for whatever the case might be, you can certainly do that as well now with the VDS. Configuration tasks. So what are we going to configure during this lesson? We're obviously going to create a new dvSwitch. We're going to add hosts and VM NICs and uplinks to this dvSwitch. We're also going to create a DV port group. It is the equivalent of the standard virtual switch port groups. We're going to create those on our VDS. We're going to migrate the legacy virtual switches, the legacy virtual standard switches, and VM networks to the new DV virtual switch and to the DV port groups. We're also going to migrate the VM kernel virtual adapters to the DV switch. This is what's going to host your IP storage, the vMotion, the fault tolerance, the management network, etc., etc. We're also going to view the dvSwitch mappings, the advanced configuration, the alarms. We're going to talk about private VLANs. We're going to talk about secondary VLANs and how you configure them and all that good stuff. That said, let's go ahead and switch into our GUI and let's start configuring some stuff. So we've logged on to our virtual center server here, and the first thing that we need to do in order to create our first VDS switch is to click on networking. Once we're there, we're going to select the data center where we want to create this, and we're going to do it under Hilton Head, South Carolina. So I'm going to right click it and drag down to where it says new vSphere distributed switch. First options that you have to select, the first choice is, do you want to create a vSwitch or a distributed vSwitch compatible with vSphere 4.0, 4.1, or 5? For the purposes of our example, we're going to go with 5. We're going to give it a default name. I'm just going to leave the default name. You can feel free to change the label here. And how many uplinks do you want to configure on this VDS? I'm going to again leave these at defaults. There's no need for me to change them. We're going to click on next. And then you need to select which host, which ESXi host you want to participate in this new VDS that you're creating. Now obviously if you didn't want to add these hosts right now, you can always add them at a later time by selecting the radio button down here. However, for me, I'm just going to go ahead and expand, and I'm going to select this particular physical NIC that I want to bind to this new VDS that I'm creating. If you click on View Details here, it'll give you some details about the particular physical adapter that you are adding. If you click on View Details for the particular host, it'll give you the number, the maximum number of ports on this particular host, etc. So I'm going to click on Cancel here, and I'm just going to keep the setting the way it is. Click on Next. You can have it automatically create your first DV port group for you, so I'm going to leave that, or you can uncheck it if you wanted to do so. And to be honest with you, you are done. You've just created your first VDS. Now let's take a look at some of the properties or some of the settings of our DV port group. So by default, it created the first DV port group for us, so I'm going to select it, right click it, and we're going to go down to Edit Settings. Now on the General tab, obviously you can change the name, you can give it a description, you have the number of ports, the type of port binding, you can go from static to dynamic to ephemeral, etc. From a policies perspective, we've covered those in greater detail on the virtual standard switches, so I'm not going to go through them again. The only thing I'm going to have you pay attention to here is the ingress and the egress. So in addition to the regular traffic shaping that you can do, ingress allows you to control or to traffic shape the traffic that's going from the virtual switch to the virtual NIC, and egress will allow you to do vice versa, so from the virtual NIC to the virtual switch, etc. So you can further control traffic shaping between the virtual devices when you're using a distributed virtual switch. That's one of the advantages, that you have much more flexibility. Everything else here we've covered pretty much under the virtual standard switches. They're all the same for the most part. You can obviously make this part of a network resource allocation or a network resource pool. You can enable monitoring, etc., etc. So if you wanted to do block all ports, right now it's set to none, but if you want to drop all the connections on it, you can set it to yes, and bada bing, is just going to drop all the connections, all the ports that are configured on it today. Security is again the same thing as with the virtual standard switches, so we're not going to cover that. Traffic shaping we've also covered with the standard virtual switches. From a VLAN perspective, right now it's set to none, which means it's not going to accept any tagging on the actual packet that's coming in. It's just going to accept it from anything. If you wanted to do 802.1q, you would select obviously VLAN, and then you can put in the VLAN ID. For example, you can do 100. If you select VLAN trunking, then what you're doing is you're allowing a range of VLANs to have access through this DV port group. So instead of creating different port groups for the different VLANs, you just create a range of VLANs. Hey, these are the VLANs that I can accept, and you just separate them by commas here. Private VLANs, as soon as you select that, it's going to throw a warning just because we haven't configured it on the switch level yet. We will do that and come back. From a teaming and failover perspective, again, we've covered all of that under virtual standard switches. Resource allocation and monitoring, you can feel free to make those configurations as you see fit. Under the miscellaneous here, again, if you wanted to block all the ports, then you can set it to yes, and voila, it's just going to drop everything. Under the advanced settings, out of the box, so to speak, when you create a port group, it's going to configure all of the ports on the port group the same way. Now, if you want to allow that, maybe you want to configure certain ports in the port group to have a different setting than the range of port groups or the port group in general, then you want to allow overrides so that you can make modifications at the port level. And to do that, you want to make sure this checkbox is selected, and then under Edit Override Settings, you have to select which settings you're willing to allow to be modified at the port level rather than being applied from the port group itself. So you can come in here and say which ones you're going to allow, which ones you're not. Click on Cancel here. And then down here you can configure the reset at disconnect, so if you just want to bring it back to the default values. So I'm going to go ahead and click on Cancel here. And now the first thing that I want to do is let's go through the creation of a port group so that we can see what does it look like when you're doing it this way as opposed to doing it from a virtual standard switch perspective. I'm going to right click on my dvSwitch here, and we're going to drag down to where it says New Port Group. You can obviously give it the name, give it how many ports you want, and then the VLAN type again. So if you want, those are the same settings that we just configured. So let's say I want to put this one in VLAN 114. I'm going to click on Next here, and voila. Very easy, very simple. A couple of more things that I want to cover with you guys before we start doing some creative stuff. Under the virtual switch itself, if you select it and right-click on it again, you have a bunch of options. You can obviously select Manage Host, and then you're managing the hosts that are available or that are participating in your virtual switch. If you right-click it again, obviously, new port group will create a new port group. You can manage the existing port groups that you have from a security perspective, traffic shaping, VLANs. So let's say if we select VLAN here, click on Next. You can go through, select which DV port group, and you can configure those particular settings. So again, just an easy centralized way that allows you to configure a lot of those settings. Right-click it again, and we drag down to where it says Migrate Virtual Machine Network. So if you're trying to migrate from your existing standard switches to your distributed virtual switch, you want to right-click the switch itself, select Migrate Virtual Machine Networking, and I'll show you later how you can migrate the kernel if you want to migrate VM kernel. You're going to select it. You're going to select the source. What are you trying to migrate to this DV port group? And let's say in my case, let's go through and select, I don't know, VM network. And what do you want to include? Like, do you want to include all the virtual machines in the network, or do you want to allow it to select? We're going to just keep this unchecked for now. And what's the destination? Where are they going to? So I'm going to leave it on the DV port group, the default one here. You can always filter by VDS if you wanted to, etc., etc. Now click on Next. It'll give you a list of the different virtual machines that you want to possibly migrate from the standard virtual switch to this new distributed virtual switch that you are creating. Now you'll notice in my case, all of them say inaccessible. And the reason they all say inaccessible is that because all of them reside on ESX1. So I must have selected a network, a VM network, that isn't configured on ESX2, thereby I can't see any of the VMs that are on ESX2. So if I click on back here, let's go ahead and select a different one. Let's maybe go through and, I don't know, let's select VM Network 3 and see if we have better success. No. Let's go with Network 2. And voila, we finally found one. It's on ESX2. So this one's accessible. So we're going to go ahead and select it. You can even expand it if you wanted to get even the network adapter itself that's on that particular server, a VM. If you had more than one network adapter, virtual network adapter, you can choose which one of the network adapters you want to migrate, etc. So I'm going to just move the whole thing, and we're going to click on Next here, and we are going to click on Finish, and it's that easy. It's that easy. It's that simple. So let me switch back to the host now and show you what happens at the host level. So if we go back to Home, go into Hosts and Clusters, we're on ESX2 here. If you click on Configuration under Networking, the standard view for the standard switches is here. Now you'll also see that FS01 no longer shows up on this list because it has been migrated from the standard switches over to the vSphere distributed switches, which now if you select on vSphere distributed switches, you can see it in here. Let's go ahead and expand that, and voila. There it is. Now, under this particular view, you have a couple of options. You can obviously manage your physical adapters. So if I click on Manage Physical Adapters, you'll see that which physical adapters are in here. You can click to add, etc., etc. I'm not going to add anything. Well, I'm just going to leave everything the way it is for now. So we're going to click on cancel here, and we can go into manage virtual adapters. If you go into manage virtual adapters, this is how you can, for example, add a new VM kernel port group to your distributed virtual switch port group, or this is how you can migrate an existing virtual adapter that's of VM kernel type to the new DV port group. So again, the process is the same. So let's go through the process of the new one. So if I click on next, it's VM kernel. Click on next again. Select a port group. Let's say you want to go with the default one here. What is it going to participate in? So select what you want it to do. Is it going to be for vMotion? Is it going to be for fault tolerance? For the management network? What is it going to do exactly? You click on next again. Yeah, we're going to ignore that for now. I know you can't do all three, or it's not suggested. Now you need to put in IP address, subnet mask, etc., etc., to be able to add those. So we're not going to go through this process. We've done it a few times. You guys should be familiar with it at this point. So I'm going to go ahead and click on cancel to exit out of here. Now if you click on the properties tab here, it'll tell you the number of ports that's currently configured or available, designated to this particular host. You can change the setting as you see fit. If you click on cancel and you click on properties here, this is how you can enable support for IPv6 just in case you were using it. Alright, so now that we've configured some of the basic stuff, let's go through and take a look at, well, how do I configure private VLANs in my environment? So let's go back to networking. And we're going to select the switch itself. I'm going to right click on it, and we're going to go down to edit settings. The network adapters here, again, it'll show you which host and which adapter on that host is participating in this vSwitch. Under private VLANs, what we want to do first is we want to give the value, the numerical value for this VLAN. So let's say, the numerical ID, the VLAN ID that we want to specify here is 100. So now we have that configured. We can configure the range, or we can configure a private VLAN range by selecting it. So if I select it here, now on the right I can specify what types of secondary VLANs I'm going to have. And this is what I was talking about during the presentation, where it's going to be clearer as we do it, because now it's going to make sense. So first one is by default, it's adding for you, it's 100, it's the promiscuous one, right? So if I add the second one here, and let's say I wanted to do, I don't know, let's do 102, and select the type. What do you want it to be? I want this one to be the isolation one. And then if I do 103, and then I would want that one to be community. Alright, so now I've configured VLAN. Private VLANs are not configured. So if I click on OK here, and if I go back into my DV port group, let's go with the default, play around with that a little bit, edit settings, and I come down to VLAN, I can select now private VLANs, and it's going to show up. And now you have the option of configuring, well, what type of port group is this port group going to be? Is it going to be promiscuous? Is it going to be community? What is it going to be? So let's assume you wanted to create this as community, because the majority of the ports are going to be community ports. Let's click on OK. Voila. Now this DV port group is going to be of type community for all of it. Now how do you check that? Well, on the right here you have different tabs. If you select the ports tab, you'll see that if we scroll a little bit to the right here, that all the ports that are inside of this port group have the community string attached to them. So you'll see you have the one here. Let me expand that a little bit. So it has the 100, or the 100, 103, which means 100 dictates that this is the VLAN ID, and the secondary VLAN, which is of type community, is now 103. Now, what was to happen if I wanted to change one of the ports? So let's take a look. So let's say, port 5, I wanted to make this particular port, I don't know, isolation. If I right click it, go to its settings, go to VLAN, whoops, I can't change. Anyone? What is the problem here? Take a second to think about this. We covered this. Why can't I change anything? Alright, so if anybody said that we didn't configure our overrides properly, then you're absolutely correct. So let's go ahead and fix that, right? So what I'm going to do now is I'm going to click on cancel. I'm going to select this port group again, right click, go to edit settings. under Advanced, and under the Allow Override, I'm going to click on Edit, and then for VLAN, I'm going to select Yes. And click on OK, OK again, and let's try this one more time. So under the port, Edit Settings, VLAN, and now guess what? Now you can override this, and let's say you wanted to put this in isolation. Voila. This will take a second, and then you will see that it goes into isolation here, and voila. It changed it automatically from community to isolation. So this is how you can move or configure the different ports on your port group to participate in different secondary VLANs if you choose to do so. Now it's worth noting here that when you added FS01 to this particular port group, it's worth noting that it took the port group ID 10. So now you know that port group 10 is associated with FS01. So these are just some things for you to get a better handle on virtual networking. You can see the flexibility, you can see the power that you're getting out of using a VDS, a virtual distributed switch. It gives you access to do much more than what you could from just using a virtual standard switch. So if you click on virtual machines here, again, it'll list all the virtual machines that are connected on this particular port group. Go to hosts again, which hosts are participating, tasks and alarms. All the others are typically the same. That's all there is to it from a DVS perspective. We're going to go ahead and switch back to our presentation and recap what we've learned. Pretty cool lesson, huh? Short, sweet, to the point. We covered a lot. So what did we cover in this lesson? We started off by talking about the vSphere distributed switch. And I know I've used the VDS and the virtual vNetwork distributed switch 100 times throughout the lesson, so I apologize, but I'm still trying to get used to it. We talked about some of its benefits, the fact that it's centralized. You no longer need to configure standard virtual switches on every ESX host that you add into your vCenter or into your cluster, and that you have a centralized way of managing it. You have advanced networking functionality that you can do. You also can take it one step further. Up until the VDS, there was really no reason, no use for your network administrator to be able to step in and take control of the virtual network. I mean, at the end of the day, I know we like to control everything, but the virtual networking piece should be the function of the network team, the network administrator, unless you're going down the route of a converged IT department where you're doing multiple things. But now you have the option of setting the boundaries on where the networking team can stop from a configuration perspective. So again, lots of benefits with the vSphere distributed switch. We talked about private VLANs and how you create private VLANs and the secondary VLANs that come out of them, and how you can create isolated and community and promiscuous mode secondary VLANs, and how each one communicates. We went through and we configured those. We talked about networking policies, the different networking policies that are available with the vSphere distributed switch that are not available with the vStandard switch, for example. And then finally, we talked about the different configuration tasks that we were going to cover and that we did cover during this lesson. I hope this was very informative for you, and I'd like to thank you for viewing.